Kia ora and welcome to question 4 of the 2011 Scholl Calc exam. This whole question is about conics. As I mentioned when we did the 2012 paper, conics used to be an external many years ago, and so there were more conics problems in scholarship. First question's about tangents and circles. Second one's about an ellipse and it's an optimisation problem, and the third one, we'll cross that bridge when we get there, but it's about a gunshot being heard by one observer and then later by another observer. That's also a conic section problem. Okay, so the first question. Two circles are defined by the following equations where r, the radius, is less than a. So let's draw a quick sketch of that. The circles are very similar except for the difference being the horizontal shift. So the first circle, if a is a positive number, which is kind of implied by the fact it's bigger than the radius, and radius will be positive, then we're going to shift it to the right by a. Not going to shift it up or down, and then we're going to have a radius of r, which is less than a. So let's make it, I don't know, something like, every video my circles and ellipses get worse. Okay, so that's that one, and then the other circle is on the other side of the origin at negative a, and hopefully I draw it with the same radius. That will do, it's a little bit better. Okay, so that one there's the right one, that one there's the left one. Find the equations of the four lines which are tangent to both circles. Four lines being bolded, they just don't want you to forget the fact that actually there's a line up there that's tangent to both, and there's a line down there that's tangent to both. So they're trivial cases, trivial tangents, y equals plus or minus r. Okay, and now the other tangents, because of the symmetry of the problem, we expect them to go through the origin. Let's draw them in a different colour. Something like that, pretty good. And that. Okay, we could just say, oh, y equals mx plus c, but you know they're going to have to go for the origin. So one of the ways to solve this problem is using differentiation in calculus, but personally I prefer to just say let y equals mx and then use the discriminant for tangent questions. It often makes the algebra a lot quicker. Okay, so if I'm what am I actually trying to achieve here? I'm trying to find the equation of this tangent, so I want to find what m is. How does m relate to a and r? Now it turns out there's actually a quicker way than what I'm going to do, but I'll leave you to spot it. It's a geometric looking at the diagram there, you might want to pause and think about it. But like I was saying, if I was to use the discriminant, and you can pick any of the equations, so let's just go with x minus a all squared plus y squared equals r squared, and sub mx into it, because at the point of intersection the discriminant will be 0, and expand that out. And then turn it into a standard form quadratic. And then just go straight to the discriminant. We don't care about the point of intersection. B squared minus 4ac. So negative 2a times negative 2a, 4a squared minus 4 lots of 1 plus m squared, which is the a thing, times by c, a squared minus r squared, that equals 0. 4a squared, now we expand that other bracket, we've got a squared is the first term minus 4 lots of it, so the a squareds cancel. We've got minus r squared times minus 4. We've got m squared a squared times minus 4. And we've got negative m squared r squared times minus 4. Okay, those disappear. We can divide everything by 4. So we've got 0 equals r squared minus m squared a squared plus 4r squared. No, that's an m squared r squared. I didn't actually divide through by m squared. What am I trying to achieve here? I want to find the gradient and how it relates to a and r. So I make m the subject of this equation. M squared a squared minus r squared. Why have I still got a 4 in that term? Equals r squared. So therefore m equals r over the square root of a squared minus r squared. So divide down the a squared minus r squared, then take the square root. And it's plus or minus because we can have a positive or negative slope as we saw on the diagram. So the equations of the lines, therefore y equals plus or minus r over root a squared minus r squared times x. Now, let's go back to this diagram and do this really, really quickly. Hopefully you spotted it, but if we just draw a right angle in there, because we know that the line will be tangent. Now, how do I find the slope of that? Well, first up, I know that this is r, and I know that this length here is a. Okay, so the other side of this triangle is a squared minus r squared square rooted. The hypotenuse is a there. And then if we want to find the slope, we actually need to know the height of that part there. So I'll leave you to think about how you could do that using that triangle, and you should get the same answer as what we got down here. You can see the similarity, but I'll leave you to think about how you get that. Think about rise over run. Similar triangles. Okay, part B, we've got this elliptical frame being built with equally bright light bulbs at the focal points of the ellipse, and it tells us in the question, although you are probably expected to know this, to be honest, it's one of the properties of an ellipse, the sum of the distances to the bulbs is a constant d. So if I take any point on the ellipse, these points here are focal points, then this one d1 plus this one d2 is a constant. And for this question, we're told it's equal to d. But that just means that in the formula, when we take x there to be the distance from the left bulb, then the other one, d minus x, comes in. For a general equation of an ellipse, if your equation was x squared over a squared plus y squared over b squared equals 1, then the distance is d1 plus d2 always equals to 2a. And you can look up on Google properties of ellipses and work out why that's the case. And that's if these foci are at this position C and minus C. And there's a relationship between A, B, and C as well. We don't need to know that for this question because the question's just asking us to find the least brightly lit points and giving reasons for our answers. We've got an equation that gives us the brightness in terms of x, and we're just trying to find that position x that gives a minimum. So we just take our equation, brightness equals intensity times 1 over x squared plus 1 over d minus x all squared. We're told that I and d are both constants, which is cool because it means it's easy to differentiate. B dash, actually I'm going to write dB dx just so I remind myself I'm differentiating with respect to x and not the other letters. I just stays in the front. 1 over x squared is x to the minus 2, so that differentiates to minus 2x to the minus 3, or minus 2 over x cubed. it's important you don't expand stuff like this out when you can use the chain rule, because we still have to solve this equal to 0 eventually. D minus x to the minus 2 differentiates to minus 2 over d minus x all cubed times by minus 1. Okay, just a quick note on that. So we've got d minus x to the minus 2. I'm taking the minus 2 down the front. D minus x power of minus 3, drop the power by 1, but I'm timesing by minus 1 because the inner function's derivative is minus 1, and I'm using the chain rule there. So it's these basic skills, the achieved questions that come back in scholarship problems all the time. Okay, we'll make that equal to 0. Now, the intensity is not 0. I is not 0, otherwise we'd have no brightness at all. So we're wanting to solve the bracket equal to 0. That will be minus 2 over x cubed plus 2 over d minus x all cubed equals to 0. Don't expand the cubic again. Just rearrange it. We've got only 2 terms, which means we can just keep rearranging. Cross multiplication. Divide both sides by 2. Again, don't expand the cubic, because then we have to solve a quadratic equation. Or we have to solve a cubic. No, we have to solve a cubic equation. We don't want that. I was just thinking the x cubes might cancel, but they don't. So what we want to solve here, we want to take the cube root of both sides. So x is equal to d minus x. There is only one real solution, and that's cube rooting both sides. It's not like when we square root, we have to go plus or minus. We don't for this. And therefore 2x is equal to d, and x is equal to d over 2. Remember that d was the total distance from the foci to the ellipse, and this is where the interpretation of the answer comes in. If x is equal to d over 2, and x was the distance from one bulb, that there's x. It's half of the total distance, so that's x as well. The bulb is the brightest, least brightest at the top and the bottom, halfway between the bulbs. Frame, did I say bulb is least brightest? No, the bulbs are just pumping out light, but the frame is being illuminated, is least bright at the halfway positions at the top and bottom of the frame. And if you're struggling to sort of describe that, just draw a quick picture and just go here and here. Now, this last question about this gunshot, I said we'd cover this when we got to it. Just like in the last problem where I talked about the properties of an ellipse and the sum of the distances being a constant, for a hyperbola, I know this question says nothing about a hyperbola, but for a hyperbola which looks like this, it can look the other way as well, but if we take the focal points, and we again call it C and minus C, any point on the hyperbola, if I take the difference between the distances to the two focal points, if I go D1 and D2, the difference D1 minus D2 is a constant, and it equals 2a. And a in this case for a hyperbola is the distance from the centre out to the vertex. And the equation is x squared over a squared minus y squared over b squared equals 1. B comes from the slope of the asymptotes, and it's the rise there, b, because the slope of the asymptote is b over a. Now, if the hyperbola opened upwards and downwards, it would be y squared over b squared minus x squared over a squared. And then actually they switch the letters around and say y squared over a squared, but never mind. Why am I drawing a hyperbola for this? It asks you to draw a diagram to illustrate the positions, the possible positions of the gun relative to the two observers. So if we say that the observers here are at the focal points, so if I go observer, who hears the gun first? Okay, we'll say observer 1 hears the gun first, observer 2 is over here. We don't know, just from the difference between like the 1.5 second difference, we don't know where the gun is. Like, that would be pretty magical maths if you could just go, oh, 1.5 seconds later, there it is. We know possibly where it is, because it's going to be on the branch of the hyperbola closest to observer 1, because they hear it first. And the difference between those distances there is the distance that the gunshot, or the sound of the gunshot, travels in 1.5 seconds. So for this particular question, d1 minus d2 equals 2a is equal to 340 meters per second multiplied by 1.5 seconds. That being obviously a distance, meters per second times seconds. 340 times 1.5 is 510. Just confirming my basic numeracy. Yep, it's 510. I wouldn't want to make a mistake there. Okay, so how does that help? We're told that's the only numbers we've got, but we know, based on our knowledge of hyperbolas and the properties of them, that this number is equal to 2a, so 510 divided by 2 is equal to 255. A is equal to 255. Okay, part C, the gun is somewhere on the right branch of a hyperbola of the equation x squared over a squared minus y squared over b squared equals 1, where a is equal to 255. 2a equals d1 minus d2, the working that I did earlier. Okay, what else can we get from this question? Oh, there is another number. I thought there would be. Okay, the observers are 3 kilometers away from each other. So because I've put this x-axis right down the line between them, then we can say that C must be equal to 1.5. Now be careful in here, because we're in meters for the A value, which means we should need to be in meters for the C value. The C value here is equal to 1500 meters. Okay, so I could say something like the distance between observers equals the distance between the foci equals 3000 meters. So C is equal to 1500 meters. C is not in the equation, but there's a formula on the formula sheet that connects A, B and C together for a hyperbola, and the formula is B squared equals C squared minus A squared. So we can go 1500 squared minus 255 squared to 184975. I don't need to find the square root of that because I just wanted B squared. Okay, therefore my equation, x squared over 255 squared minus y squared over that number equals 1. And I can say where x is greater than 0, because we know that the gunshot must be closer to observer 1 than observer 2. Again, quite an open-ended problem, just like question 3C was in this exam, or the question about the boulders. I think it might have been 3B. But yeah, it's quite an open-ended question, not really much to give it away where you start it. And I guess you had to really know your really know your stuff to do with conics there, because if you didn't, you would have had to set up some sort of equation using trigonometry, Pythagoras, which you could do, but the question said that we needed to choose an appropriate coordinate system, right? So we put the observers in, like I did before. We call this point xy, which we don't know its equation. Suppose we don't know anything about hyperbolas at all. And then we're just out to prove that this locus is a hyperbola. And then we're going to make this distance here. We're going to use Pythagoras to find it. So d1 in terms of Pythagoras. We're going to do d2 in terms of Pythagoras. We're going to set up that d1 minus d2 is equal to, what was it again? 510, I think. But then we're going to write d1 and d2 in terms of c's and x's and all that sort of stuff. It's going to have double square roots in it. I challenge you to work it through, but it's really tedious. But it simplifies a heck of a lot, because all of the terms go together, cancel and stuff, to be left with such a beautiful equation at the end.